All right, let's get this show on the road. Good morning, everybody. This quote is very applicable to, well, just about everything, right? Problem with communicating is people think they have successfully done it and then proceed to stop. So, please let me know if I am effectively communicating today, or at any point I need to repeat myself, okay? Keep that in mind. With that, let's take a look at our, that's geometry every time. Gotta set this up. All right, graphing polynomial functions. So, yesterday I hit you with the big notes, tons of stuff all at once. Now you're gonna take all that stuff and put it together and just practice sketching up some graphs. Fair enough? Put it to good use. And we're gonna take this in two stages here. So today's stage one is the quick and dirty sketch. Okay? Use what you got, what you already know about polynomials and their features, plus the information about end behavior from yesterday, right? So you know how many twists and turns there's got to be. You know the maximum number of roots there's got to be. You know what directions the 2 points, the end points, the arrows off the end, what directions those have to go in. Okay? And use that to create quick and dirty graph, a sketch of a graph. Okay? That's what we're going to do here. We're going to get the maximum number of turns, take a sketch, and the number of real zeros. It's really maximum number of real zeros, because we're not going to do any calculation. No computation today, okay? Except reading off, right, the power and the coefficients, and one extra little trick I'm going to throw in there, and of course the constant term. We'll make use of that as well to give our graph a little bit more verisimilitude. But we're not going for the best graph. We're not going for the realistic graph. We're not going for any kind of usable accuracy. We're just going for image, right? If you were to see this graph from across the room, could you recognize it? That's all we're looking for. And then tomorrow, we will add on the extra layer where we will revisit this exact same worksheet, except I will not scratch off the approximate zeros to the nth, approximate relative maxima and minima, because tomorrow we'll add in the graphing calculator. We'll have that give ourselves a much more accurate graph, and then from that you can copy down there and approximate the zeros based on the graph. All right, so that's the stages we're going to work at here. So, start with real simple example. Take a look at number one. What do you notice about that power? Power is 2, right? Which means we already know, oh, it's a quadratic, it's a parabola. I know how to graph those. You know all about those. Stop that. Stop it right now. Hold your horses, man. Okay, I know it's a quadratic. I know you know all about it and how to do it. But let's use that as our test, because we can check using our quadratic knowledge how good of a job we've done. Let's apply the general polynomial techniques here and see if it checks out. All right, so 2 is even, right? So we're going to, and the sign on here is positive. So my end behavior is going to be an up and an up, right? That's what we should expect to see. Because even, same direction, positive, ends going up, match that with the first side. Whichever one you think of as first, right? And then we want maximum number of turns. Well, if the power is 2, we subtract 1. So how many turns do we get? 1, right? How many zeros? Yeah. Maximum possible equals that 2, right? And then let's add one extra thing. This is the extra little bit we can do on any polynomial to get slightly more accurate, right? And this is the only piece of accuracy we're gonna steal here, and that's the y-intercept. Because it's just the constant term, whatever that is off the end. You don't have to, technically you're putting 0 in, right? But when you put 0 in, everything with an x dies off. The only thing left is the constant. So just read the constant term, and you instantly know your y-intercept. So you have a starting point on your graph. So you know, okay, well the shape is points up in both directions, turns around once, so it's a U shape. But where does that U shape go? That's always the question. Where do I put it? Is it over here? Is it over there? Down here? Up there? Right? You can place it anywhere. We're going to assume it goes through the middle, so just keep it about symmetrical. Don't stick it over here or over there unless you have reason to. And we know our y-intercept, so we're going to drop it 1, 2, 3, 4, 5 down there. Right? Maybe make that a little bit taller since it starts so low. Extend your ends up a little bit. Okay? Fill the whole graph. There we go. Right? There. Parabola sketch. Does that match with what we about would have expected from what we know about parabolas? Absolutely. Right? Positive, opens up, U shape, both go in the same direction. It checks out. Right? The only question is, where did these guys land? Right? And that would require a little bit more knowledge to be more precise there. We would need to do some more computation to figure out, okay, is this like tall and skinny? Should I have gone a little more through like 3 instead of 5? Should I stretch it out to 8? I don't know. I don't need to know right now. We'll save that bit for tomorrow, right? Tomorrow we'll get more accurate because you'll pull it up on the calculator and be like, oh, that goes through about 5. Okay. Right? You'll base your graph on that. But for right now, this is all I'm asking for. Quick sketch. Give me this little summary of information. Stop there. And do that for all, 8 of them? 7 more graphs. Any questions? No? All right. Then have at it.